Alright, so this screencast is about nuclear decay. We're going to talk about 4 kinds of nuclear decay, starting with alpha decay and the element uranium-238. So if you watch the equation down here, we'll explain what you see happen in the simulation up here. We see 2 protons and 2 neutrons exiting the atom, and down here we see that our uranium has lost 4 particles, the 2 protons, 2 neutrons, so that's gone down 4, but also because we've lost 2 protons, our atomic number has gone down 2, changing the element to thorium. And here we see, over here in this helium, the 4 and 2, that's our helium element. So that's what happens in alpha decay. If we take a look at what beta decay does, we're going to use carbon. And proton and neutron are freaking out, and it makes an electron leave. And because an electron is leaving, we now have an abundance of protons. So our atomic mass stays the same, but because there's a plus in protons now, the atomic number goes up, changing our element to nitrogen. And here is our little electron. So let's take a look at positron emissions. It's trying to become stable, it's decaying, and a positron is leaving. So because a positron is leaving, there's now an excess of electrons here, and so our carbon goes down because of, the positive's gone, and we now have boron, and we're a plus in our electrons right now. And one more electron capture, we're going to use tungsten. We bring in an electron and it begins to fall down all of the shells, all into the nucleus. So now what we have is that our mass number stays the same, but we do go down 1 because we now have an excess of electrons. So we go from tungsten to, I believe that is thallium. And that is how the 4 different kinds of nuclear decay work. Hey!